Hello and welcome everybody. I'm joined here today again by Estera, which means we're going to talk Apache Spark. And today we're going to focus on something very specific. Because we're working here for Microsoft, we're going to talk about Apache Spark on Azure. Now, before we dive into Apache Spark on Azure, Estera, can you please enlighten us on the architecture of Apache Spark and how it actually works?
So this part may be a little challenging, but I will use simple terms to simplify it. So let's break down the main components of Spark's architecture. Starting from the left side. So a Spark cluster is made up of nodes, which are just computers connected together. They work as a team to process loads of data really fast. In a cluster, there is a master node that acts as a boss, and there are worker nodes that do actual work. The master node has something called driver program. You can see it's a yellow rectangle. And that is what drives your application inside the cluster. Inside the driver program, there is something called Spark context. Think about that as a gateway to all cool stuff that Spark can do. Everything you do with Spark goes through the Spark context. Now, Spark context works with cluster manager to manage jobs. So when Spark context get a job, it breaks the job into smaller tasks and sends them to workers. Each worker node has one or more executors that are running tasks. They run several tasks at the same time in a different JVM threads. And that is why data processing is super fast. That is the secret.
Okay. Wait. So you're mentioning jobs, tasks. Can you clarify it a little bit more?
We'll try. But before that, I want to clarify one more aspect, the beauty of Apache Spark. So Spark splits large data sets into smaller pieces called partitions. Each partition has a chunk of data that can be processed independently and in parallel across all the nodes in the cluster. Let's talk about the flow of Spark application. It starts when users are writing application code, which has some data transformations, for example, filtering, and some actions like count, just to count how many records, rows we have in the data. And when an action is called, that is the place, the time when things kick off. So the Spark driver program analyzes the dependencies between transformations and it creates execution plan. Then it divides the plan into one or more jobs for further splits each job into stages. So we have job, then stages, and stages are split based on the dependencies between these mentioned transformation. So there are two categories of dependencies. The first is wide dependencies, like group by key, and we have also narrow dependencies, the second category, like mapping. So what is the difference between them? The difference is that wide dependencies need data shuffling, and that is going to be cost, because it's data shuffling between partitions, while narrow dependencies can run transformation within the same stage. So now we are done with explaining the stages. Going to the last pillar, let's focus on task. So the driver program generates tasks for each stage, and each task work on a single partition of data. Tasks are sent to executors, which process them at the same time concurrently, and they can also store immediate data in memory and also on a disk. And when the task is finished, the results from task are combined, from all the tasks are combined, and as the next stage, the next stage is that the next stage is executed. So tasks are executed in the same time, stages sequentially, one after the other. So finally, once we complete all the tasks, all the stages, the results are returned to the driver program and saved to external storage depending on the action that is specified in the Spark code.
Okay, that sounds awesome, but it also sounds terrifying. Is there an easy way to run this, or do I always have to do this full setup?
So if you want to run it and manage on your own, yes, you have to know the terminology, all the rules. But the simpler way is to use a PaaS or SaaS way to run Spark on Azure. So
Okay.
we can distinguish 6 different ways to run Spark on Azure. The decision what to use and when to use it depends on whether we want to have a Spark that we are going to manage, we are going to configure, or we would like the cloud provider Azure to do that for us. So let's start from the easiest option, starting from the first one, Azure Synapse Analytics. So here you just create Spark within Spark Synapse workspace, Synapse workspace. The service Synapse handle the configuration, the management of Spark cluster, making it super useful and easy for you to start the data processing. The second, Databricks. So here you set up a Databricks workspace and clusters. It's pretty similar to Synapse Spark. Now let's move to the slightly more involved option, the third one, Azure HD Insight. So here you create HD Insight Spark cluster. You configure storage account. You submit Spark jobs, and that takes a bit more work compared to Synapse and Databricks. That's why it's moderate. If you want more challenges, you can also run Spark on virtual machines. So here you provision VMs, you install Spark on your virtual machines, you install all the Spark dependencies, you configure networking, you configure storage, you manage Spark cluster yourself. That is pretty challenging. That's why name is like the card is, it's difficult. For those who want even more control and even more challenges, you can also deploy Spark application using Kubernetes. So here you will need to understand Kubernetes concept to set up a Kubernetes cluster, to create Docker images for your Spark application, and you will use Kubernetes for deployment. Lastly, we have also Azure Batch. Here, it's a moderate options because you create a Spark pool, you configure VMs and storage accounts, and you submit Spark jobs. And this approach requires more configuration than Synapse.
Okay, awesome. That basically shows us all these different ways of running Apache Spark. But it's Azure Synapse Espresso. So how do we do this in Azure Synapse, and how is it actually positioned in Azure Synapse?
So we have to touch what is the difference between Synapse Spark versus OSS Spark. The main difference that between Synapse Spark and OSS Spark, open source Spark, is that Synapse Spark is a managed service managed by Microsoft Azure. It fully integrates with other Azure services. So you can see on the slide, it integrates with Azure Machine Learning, Power BI, it uses Azure Active Directory for authentication and authorization, and out of the box, it can process data stored in various Azure services like Azure Data Lake Storage, Gen 2, Blob Storage, SQL, Cosmos DB, and also it has built-in security, compliance, and management features. On the other hand, open source Spark is an open source platform deployable to any infrastructure, so it demands more effort, more expertise to create, provision, to manage. OSS Spark, as its open source project, does not include any Azure-specific features by default. You can access the source code of Apache Spark on GitHub. You can check the instruction how to set up on your local PC, on like different clouds, and you can see how difficult it is and time-consuming to provision, to manage cluster, manage data, scale the workers. That's why PaaS or SaaS approach towards Spark is what our customers want to have.
Awesome. So that basically concludes this video. So we've showed you 6 different ways of running Apache Spark on Azure. One is more easier than the other. So you have the different SaaS, you have the PaaS way of doing this. And in next videos, we'll start focusing on the Apache Spark runtime. And we'll look at the native mode that we basically have in Azure Synapse Analytics. Now, if this was the first time you're visiting our channel and you like the content, make sure you hit that subscribe button. If you like the video, give us a thumbs up. And if you have any questions for us, just write them in the comments and we'll definitely get back to you. As always, from the Azure Synapse Espresso team, this is Stijn.
And Estera.
Bye. Thank you for watching.